Earth's magnetic shield is not permanent. The planet's core controls magnetic protection. Magnetic reversals have happened many times before. Field strength changes are measurable and ongoing. A weaker field does not mean instant disaster. Earth's magnetic field is generated deep inside the planet, within the liquid outer core, about 3,000 kilometers below the surface. This region is composed mainly of molten iron and nickel, and its motion produces a process known as the geodynamo. As Earth rotates, convection currents in the electrically conductive liquid iron create electric currents. These currents generate a magnetic field that extends far into space, forming the magnetosphere, a protective shield against solar wind and cosmic radiation. However, satellite data shows that Earth's magnetic field strength has been weakening by about 5 to 10% over the last 200 years. This decline is not uniform. Some regions weaken faster than others. One of the most notable anomalies is the South Atlantic anomaly, a large region stretching from South America to southern Africa, where the magnetic field is significantly weaker. In this zone, the field strength is roughly 30% lower than the global average, allowing charged particles to penetrate closer to Earth. Satellites passing through this region experience increased radiation exposure and system errors. The weakening occurs because the flow patterns of molten iron in the outer core are changing. Seismic studies and magnetic modeling suggest that large-scale fluid motions are reorganizing the geodynamo's structure. When these flows become less coherent, the magnetic field weakens. Importantly, this behavior is not unusual. Geological records preserved in volcanic rocks show that Earth's magnetic field has reversed polarity hundreds of times over the past 160 million years. On average, reversals occur every 200,000 to 300,000 years, though intervals can be much longer or shorter. During a reversal, the field does not simply flip instantly. It weakens, becomes complex and multipolar, and then re-establishes itself with opposite polarity. This process can take thousands of years. A weakening magnetic field does not mean Earth loses all protection. Even during past reversals, the field never dropped to zero. The atmosphere also provides significant shielding against harmful radiation. However, a weaker field does have consequences. It can increase radiation exposure at high altitudes, affect satellite electronics, disrupt radio communication, and intensify auroras at lower latitudes. In summary, Earth's magnetic field is weakening because the dynamic flow of molten iron in the core is changing. This is a natural, well-documented planetary process, not a sign of imminent collapse. The magnetic field is not a fixed feature. It is a living product of Earth's interior dynamics.